Welcome to Summarized Science, where the cutting edge of physics is explored. Scientists are currently trying to solve a massive riddle called the Hubble Tension, which is a disagreement over how fast the universe is expanding. This value, known as the Hubble constant, helps determine the age and eventual fate of everything in existence. To get a clearer picture, researchers are turning to gravitational waves, which are ripples in spacetime caused by massive cosmic collisions. These ripples travel across the universe at the speed of light, carrying information about the distance of the source directly to detectors on Earth. These events are called standard sirens because they provide a direct way to measure how far away a cosmic explosion occurred. Unlike stars or supernovae, these sirens do not require many complex assumptions about their intrinsic brightness to calculate distance. Most of these collisions involve binary black holes that do not give off any light, making them dark sirens. This makes it tricky because there is no flash to point out exactly which galaxy the merger happened in. Because these dark sirens are invisible to traditional telescopes, scientists have to use massive galaxy maps to figure out which galaxy likely hosted the event. They use the DESI Legacy Imaging Survey, which covers a huge portion of the sky containing millions of potential host galaxies. This specific study looked at 17 different cosmic collisions, including 7 brand-new events from the most recent observing run. These 7 events were selected because they were well localized, meaning their position in the sky was relatively clear compared to others. To make the measurements more accurate, a deep learning model was used to predict the distances to galaxies within the search area. This neural network helps estimate the redshift, which is how much the galaxy's light has been stretched by the universe's expansion. The researchers also accounted for the fact that mergers are more likely to happen in bigger, brighter galaxies. They applied a weighting system based on the light output of the potential host galaxies to refine the statistical odds. Interestingly, the study found that including this galaxy brightness data shifted the results toward a slightly lower expansion rate. It shows how every piece of information about the surrounding environment helps sharpen the understanding of these sirens. When looking at individual events, the results show how some collisions are much more informative than others. Some provide broad, fuzzy results, while others point toward a very specific value for the expansion speed. By combining all 17 dark events together, a much more precise and reliable value for the Hubble constant begins to emerge. This statistical approach turns many uncertain signals into one strong piece of evidence for the expansion rate. The real breakthrough happens when these dark sirens are combined with the famous bright siren event from 2017. That event was unique because it was a neutron star merger that produced a visible explosion seen by telescopes worldwide. The final result of this massive calculation is a measurement of the Hubble constant at approximately 69.9 kilometers per second per megaparsec. This result is a major win for the standard siren method of measuring the universe. This represents an 11% improvement in accuracy compared to previous results that only used that single bright event from 2017. It proves that even dark, invisible events can provide critical scientific data when analyzed with advanced technology. In the future, as gravitational wave detectors become even more sensitive, astronomers will find hundreds of these events every year. This will eventually allow for a measurement of the universe's growth to within an incredible 1% accuracy level. The future of astronomy is no longer just about light. It is about listening to the vibrations of the cosmos itself. This work brings everyone one step closer to solving the mystery of how our universe began and where it is going.